This video will demonstrate some features of the torque analysis software package and a brief introduction of how different cycling techniques can be recognized with this software. Two different cycling techniques will be seen here. The first being short duration power regions, where peak power developed is quite large, however the average power over the complete rotation is averaged out. Considerable losses will be seen with this technique. The second technique will be focusing on reducing the rear foot drag as much as possible. While the forward foot power is less than the previous case, the reduction in drag or losses of the rear foot results in an equal average overall power. The time graph of the power shows two distinct regions of where the rider has been cycling. From the power measurements alone, there appears to be relatively little difference between these two regions. Selecting to display the individual left and right power values, it can be clearly seen that something has changed about the rider's technique. In the first power region, the left and right power values are quite similar. In the second power region, it is clearly seen that the rider's right leg has become dominant and the left leg is producing approximately 30% less power than the right. While this difference is clearly visible, what is currently unknown is what changed about the rider's technique to cause such a massive change in the rider's power balance. This is where the torque analysis available on the Biobike will provide some answers. Selecting the torque button will bring up the polar graphs for left and right legs, providing visualization of the vastly different technique being applied. These polar graphs show where in the rotation the power is being produced or lost and is much more informative. The red circle is the zero line where neither positive nor negative power is being produced. If the trace moves outside this circle, positive power is being produced, and if inside, then negative power or a loss of useful power is being observed. The circular nature of these graphs represents the circular motion of the rider's foot, with the front of the cycling rotation being the right side of each circular graph, or if using the analogy of a clock face, the 3 o'clock position. The 12 o'clock position is where the rider's foot is at the top of the rotation, and 6 o'clock at the bottom of the rotation. For the first technique, a considerable inefficiency exists where the rider is actually fighting themselves, and while producing power with the forward foot at around the 4 o'clock position, is at the same time absorbing some of this power with the opposite leg around 10 o'clock, and therefore wasting a large portion of the power being produced. In contrast, the second technique shows the rider is now focusing on reducing the amount of lost power. The power previously being lost by the rear leg is now practically zero. And even though the power of the forward leg is considerably less, the overall average power of the rider is approximately the same. The change in balance of power between left and right legs appears to be primarily around the 9 o'clock position, where the right leg is clearly pulling up stronger than the left, even to the point of producing positive power in this top region of the rotation.